Hello, Accelerated Chemistry students. This is Ms. Krista Foley, and this is your Chapter 2, Section 1 video notes all over the properties of matter. Before we can start talking about the properties of matter, though, we need to talk about how we describe matter. So properties that describe matter can fall into two categories. So we have extensive properties and intensive properties. And this image at the bottom here shows how we can describe matter. We can talk about its texture, what actions it does, its shape, its mass, its volume, its density, size, and color. So let's first talk about extensive properties. Extensive properties depend on the amount of matter of a substance. So mass is the amount of matter that an object contains, and the volume is the measurement of the amount of space an object occupies. So as you can understand, these two properties depend on how much of the substance you have. If you had a little bit of aluminum, then the mass would be small. If you had a lot of aluminum, then the mass would be larger. Same thing with its volume. Now let's talk about intensive properties. So these do not depend on the amount of matter, but the type of matter. So intensive properties would be something like odor or color, absorbency. Now let's talk about how we identify this substance. So matter that has a uniform and definite composition is called a substance. Every sample of a given substance has identical intensive properties because every sample has the same composition. So we can describe matter using their physical properties. So a physical property is a quality or condition of a substance that can be observed or measured without changing the substance composition. So hardness, color, conductivity, malleability, melting point, boiling point. Those are all physical properties, because if you check to see how hard something is, or the color, melting point, boiling point, you're not changing the identity of the substance. You're not changing its composition. So physical properties can be very useful to help chemists understand and identify the substance. So substances that are similar will have at least one physical property that will make them different. So let's talk about some states of matter. Some of these you're going to be familiar with, and some of them are going to be completely different. You probably never heard of them before, so we're going to go through them. There are 5 states of matter. Solids is first, and it has a definite shape that does not depend on the shape of its container, a definite volume. The particles are packed close together and in an orderly arrangement. They're incompressible, which means that if you push on them, they don't move very much. They don't get closer together. They expand slightly when heated. Now remember, when I say expand slightly, I mean the spacing between the particles is going to get larger. The particle itself does not gain in size. It's just the space between the particles that will expand. They vibrate in place as well. They have a very low kinetic energy. Remember, kinetic energy is the energy of motion. And so if they have a low kinetic energy, that means that they're not moving very fast. And when we write them in a chemical equation or in a formula, and we want to shorthand what state of matter it is, we write an S next to it. The second state of matter is liquids. Liquids have an indefinite shape, but will take the shape of the container. So when you pour water onto a counter, it spreads all over the counter, but when you pour it into a glass, it takes the shape of the inside of the glass. It has a definite volume. The particles are close together, but far enough apart so that they can slide past each other. The arrangement of particles is not rigid or orderly. They have a flowing motion. They're almost incompressible. Now, liquids have a little bit more space between the particles than solids do, which means that you can push on them a little bit to get them closer together. And they tend to expand slightly when heated. Once again, remember, when I talk about they tend to expand slightly, that means that the spacing between the particles increases, not the actual particle itself. And they have a moderate kinetic energy. And we use the symbol L when we're writing it in a chemical equation or in a formula and we want to shorthand what state of matter it is. Or if it's AQ, that means that we have a water solution. So aqueous means that something is dissolved in water. It's a solution. The next one is gases. Gases have an indefinite shape. They take the shape of their container. They have an indefinite volume, which means that they will expand to fill any container that you put them in. The particles are very far apart. They're easily compressed to a smaller volume. So since those particles are so far apart, you can put pressure or push on the gas particles and get them to move closer together. They move in a constant, rapid, random, straight line motion. So gas particles will move in a straight line very, very, very quickly until they hit something, the walls of a container, the walls of a room, and then they bounce off and they move in the opposite direction, also in a straight line. They have very high kinetic energy, and we use the symbol G to describe them. Now, let me get one thing a little bit clear with you. There are two words that people use interchangeably, and those are gas and vapor. The term gas refers to the state of matter at room temperature. So oxygen is a gas. If we're talking about a vapor, that would be something that was once a solid or a liquid and has been heated to undergo a phase change to go from a solid or a liquid to a gas, and that is a vapor. So it's water vapor, not water as a gas. When we heat liquid water up and it becomes a vapor, that is when it has gone from the liquid phase to the gas phase. So it's water vapor. That's how you use those terms properly. Now, the next state of matter is probably not as familiar with you. You might have heard it before, but it is called plasma. Plasmas are very high energy states that conduct electricity. They are composed of a mixture of ions, electrons, and neutral atoms. Group 1 elements, so the elements that are in column 1 on the periodic table, usually are the ones that are going to form your plasmas. They exist at very high temperatures. And then the last one is Bose-Einstein condensates. Bose-Einstein condensates emerged in 1995. Boulder, Colorado, and MIT in Massachusetts were working on this project. And it is basically a superfluid. It exists at almost 0 degrees Kelvin. And the particles behave like waves. And it is giant matter wave that is produced. So if we look at the picture on the right, if we were to look at particles and think about particles, we think about the top. When those particles start to slow down, and when they start to slow down so much so, they start to expand and become waves. And when they become waves, they start to slow down so much that they start to overlap and they lose their own identity and they start behaving as one wave altogether. And this type of matter displays unique and bizarre characteristics. All right, so we've talked about describing matter, we've talked about the types of matter, we talked about physical properties of matter. Now let's talk about physical changes. Physical changes occur during matter. They happen, and basically what we're talking about here is that you change the matter somehow, but you don't change the composition. So no new substance is created when something undergoes a physical change. So what would be considered a physical change? A physical change would consist of, if you were to look for it in a problem or if you were to look for it in a descriptor, you'd look for words like boil, freeze, melt, break, split, grind, cut, and crush. All of those words describe changes that you would do to matter that would not change the identity of the matter. And so when we're talking about physical changes can be classified as either reversible. So for example, if we were looking at phase changes, when something goes from a solid to a liquid or when something goes from a liquid to a solid, that would be a phase change. And that would be what we would call a reversible physical change, because the identity of the matter does not change. When you melt ice on your countertop, it is water when it's in the solid form as ice, and it is water in the liquid form as it melts on your countertop. Those are reversible. You can change that liquid back into a solid just by lowering your temperature. Then we also have irreversible physical changes. Irreversible physical changes would be something like breaking it into pieces. So if you were to take a piece of paper, rip it into small pieces, you cannot undo that and put it back together. That would be the difference between reversible and irreversible physical changes. Well, this is the end of your Chapter 2, Section 1 video notes. And as always, all of the information in these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition of the textbooks, resources, CD, and pearsonchem.com. Thank you.